we share the slides. You should see the presentation back again.
Yes.
And you can hear me. Perfect. Thank you, Federico, for the nice presentation on Countdown. So I will now take word back and speak about the Examon project and the Examon tool. So Examon stands for Exascale Monitoring Framework. It's been developed, started in 2014 together from University of Bologna and Cineca, and has been also applied in several projects together with the for computing engineering, where also now has been technology transferred to E4, which can also provide commercial support on the tool. So the idea of Examon is to collect everything from a data center in the most flexible way, and then use state-of-the-art AI and big data processing techniques to extract value from the data which are collected. So at the same time, also provide dashboarding and connectivity to the flow of data to different tools, as well as dashboarding for the system administrator, facility managers, and user support team in a data center, as well to the end users. So the Examon project started in around 2014. In 2015 has been installed to a set of increasingly large machines installed in Cineca. Within the period of 2021-23, we reached a maturity phase of the tool. It has been installed on the Marconi system, Marconi 100, and during the period of the Marconi 100, it was collecting around 1 million of unique sensors and having a database of the collected metrics, which was growing. It was at the level of 30-40 terabytes of data collected. In 2000 and 2023, the main developer of the Examon tool, which is Francesco Beneventi, which was a researcher here at the University of Bologna, has been hired by E4 Computing Engineering, and now the Examon tool can have commercial support by E4 company, which is a really success story in a sense that by being a university tool, it was not really easy for us to maintain the tool in a complex data center infrastructure, and now there is a commercial backup for support of it. The research activity ongoing in Examon tool started in beginning 2021 and then ramped up in 2023, and now focusing on applying AI techniques to the data which are collected for anomaly detection, anomaly prediction, and in general data center automation. Recently, the tool the data collector are fully integrated with Python, so it's possible to run standard ML and machine learning and artificial intelligence pipeline on the data collected. And recently, we also connected it with MLOps framework for deployment for continuous integration and continuous deployment of AI pipeline directly in production. The tool is open source and can be used by everyone. So the Examon structure is built in layers. So the two main components are the backend component, which are plugins, which interfaces with different sensors in the data center. Sensors can be hardware or virtual hardware and software sensors, and these each of the sensor metrics is pushed toward a database backend by leveraging MQTT protocol, and more specifically the Mosquito implementation. Data are then stored in Cassandra database for gaining horizontal scalability. So and which is also represented by the data that Examon is capable to store and to ingest. And then application layer, so which consists of extracting information out of the data, both in real time and based on batch. This goes through classical machine learning interfaces. The tool is integrated with standard deep learning and machine learning technologies, which give it flexibility on the creating application around the data collected. Of course, data are also visualized to Grafana, so dashboard can be configured and designed for the data which are collected. So at the base of the transport of the data between the front end and the back end, there is the MQTT telemetry transport. So basically, the data collected are tweeted to a database. Where Examon is different from other technologies, so monitoring, holistic monitoring of data center has been seen in the last 4 to 5 years, different technology, also open sourced. Examon used standard technologies, and it has a flexible way of encoding the information of the metric which is monitored within the topic of the MQTT message, and this then based on the structure on the MQTT message topic, the data are inserted into the database. This gives flexibility in a sense that Examon, whatever sensor is sent to the data broker in Examon by using this format, is automatically stored in the database, and gives flexibility to have dynamically changing sensors, virtual sensors, which are added to the Examon database. So these we saw in the years of Examon to be something which is a plus, which is needed in a sense that a data center is not really static infrastructure. So there are always some new components which are added, hardware and software, and the fact of not having to maintain the backend part of the data ingestor, it is a plus. In that sense, it's just important, once a new component is added, it is important to add the new publisher to that component, which reads the data from the data source and send it to the broker of the Examon system with the correct formatting of the topic. And then automatically the system will read it and store it in the Cassandra database. So the topic are organized in key value pairs, so which identifies the key and the value, and then stores by adding tags to the database. So MQTT, we have different sensor publisher, which are software entities which collects data and send them to the MQTT broker based on topics which describe the properties of the data source. Each data point is the payload of the MQTT messages that is composed by a value and timestamp. So it's numerical value and the time. These data are then propagated to MQTT subscriber, and this allows also to have real-time data consumers of the data, which can also do data processing pipelines, basically on the stream of data. Whereas for the storage into the Cassandra database, we use Kairos. Kairos DB is an abstraction on Cassandra, which creates time series columns in the Cassandra database, and we have a component in Examon which collects the data from the broker and organizes them into different Cassandra database columns according to their data tags, where tags are extracted by the key value pair of the topic of the message. This gives absolute flexibility, because if we want to add the new sensors, we will just add the new publisher to the MQTT broker, which will send data to the MQTT broker with the different key value pairs, and this will automatically create new metric columns into the Cassandra database, which can later be retrieved. So the structure of Examon is based off plugins. So the plugins have the role of fetching data from the different to publishing data from the different components, and within the Examon project we developed almost all the plugins which are needed for monitoring a data center. And this goes from facility data to system administrator usually collected data and user support collected data. And this connects to the different multitude of software which does monitoring, partial monitoring of specific components in the data center. We also have a data publisher which connects to equipment such as room data, so cooling equipment, power PDUs, electrical panels, and also external environmental sensors, so kind of virtual sensors. So for instance, if you want to add to your data traces what has been forecasted as an environment temperature, you can directly collect this data by the weather forecasting agency by having by using web interfaces. So so this allows you to have with a rich set of sensors which are stored into the Examon in the Cassandra database and the Examon backend, which then can be used for doing extracting information and doing improvement on energy efficiency and also sustainability of the center. So overall, the system, the Examon system, when installed in Cineca, was running in a cloud partition of the Cineca resources by several virtual machines, which were used to handle the horizontal scalability of the volume of linked to the volume of data which were collected. So the flexibility given by Cassandra database is indeed in the fact that if the more sensors are needed, a larger volume of data is needed for having full monitoring of the system, additional virtual machine can be added to cope to handle this additional data volume, still maintaining the same data access interface. When we made measurements on the benchmarking measurement on the cloud partition where we were running in Cineca, we saw that the performance of the cloud partitioning was competitive with a commercial solution from AWS and Azure in terms of I/O operations and bandwidth of the collected infrastructure. So the Examon machines were running in resources which were state of the art in terms of capabilities. What then we invested in time in collaboration with Cineca was in creating a set of dashboards that were needed by the different organizations within the data center, within the Cineca data center. So we had we integrated Examon with set of tools which allows to have a flexibility in creating dashboards. So with we provided SQL capabilities to Examon. We integrated with Redash and Superset for doing flexible dashboards and analytics. We also connected with big data analytics to extract information by to be more, let's say, productive from data analysts in looking at the data, and as well we provided the multiple dashboard for the end user operator. We saw in the project we had really great opportunity and fruitful collaboration with the different Cineca internal organization in training them for creating dashboards, which then have been used in production for monitoring the data centers, and we both from the production as well as from the facility side. So we also, in the course of the last year, we integrated the Examon with 3D libraries, which are supported by the Grafana, which allows also to create interactive and virtual reality, augmented reality dashboards, which can allow us to have a spatial view of the data in the data centers. This has really become handful in a sense that allows to see spatial correlation of the data, fastly identify at spot, and also can be used for having large control room of the data center, avoiding having the operator to enter the room to understand ongoing problems in the management of the system. One of the here it's a live view of the the dashboard on the Marconi 100, where data were with 3D visualizations, where we could add the different data planes to the graphics, which can be used to spot hotspots in the system. We also added additional graphical components and visualization components for the cooling equipment to understand at the same time the level of efficiency and the capacity of the different cooling system. Indeed, here in the picture we have the Marconi 100 room, where we have the 6 crack, which were room air conditioner, which were in the room, as well as the liquid circuits. And Francesco Beneventi added this visualization, which was in a level showing the cooling capacity of each of the equipment, and in color the efficiency of each of the component. So this could be used to have a glimpse of the current status of the cooling system compared to the heat which is produced by the machine, understanding which part of hybrid cooling system is efficient and is saturating its capacity. Thanks to this visualization, we had a collaboration with the facility group, and we designed a specific dashboard to track the coefficient, the efficiency in terms of COP of the different cooling circuit during in real time. And this was given, this dashboard was given to the operator, which then could use it in real time to understand for the different cooling system if the cooling equipment was running efficiently, and to tune the set point of the cooling efficiency of the cooling system in real time. The effect of this dashboard was in a decrease of 8% of the PUE of the Marconi 100 system, because the operator was capable of having an augmented visualization of the efficiency of the cooling system, and directly set the parameters, the operating parameters of the different cooling equipment to lead to a benefit. So the bottom plot shows the historical histogram of the Marconi 100 PUE, and the improved one under the same conditions after this dashboard was put in place and the operator was trained to use the dashboard. So this is really an impact of having a holistic monitoring system and flexibility tool in order to generate visualizations. The next part of the presentation goes on the last chapter, which is what we have been investing together with Cinecca and our research partners in creating AI, in applying artificial intelligence tools to the collected data by Examon. So here I must acknowledge the work done by Andrea Borghesi, which is and the AI group in the University of Bologna, with which we have been collaborating through the last decades to create the AI technologies connected to Examon, and also to the different PhD students and past students that has been working on the project. So one of the byproduct result of this research activity has been a release of the largest data set of holistic monitoring of HPC system. This is thanks also to Cinecca, which allows us to publish the data which have been collected, and of which we released the entire lifetime of Marconi 100 holistically monitored in publicly available on the node within a accompanying paper on Nature Scientific Data. The data set is composed of 50 terabytes of data uncompressed, which covers the lifetime of the 980 compute nodes, room, and equipment of the Marconi 100 data, where all the different components have been monitored during the period. We also, in doing that, we had the practice in creating data sets based on collected holistic data. It was a process to clean the data, which took us around 6 months. The most, let's say, of the pain has been in homogenizing the data stamp, the timestamp values in the monitored system, and also to compress the data. Indeed, by applying different strategies, the decreased by 50 terabytes to hundreds of gigabytes in terms of by leveraging different strategies of compressions. The metrics collected by Examon are records the way in which they are collected. So we have different metric points with several tags, plugins information and tags, which are metadata associated to each of the monitored values. And these are in Examon, we created an interface, which is Examon QL language, which allows you to query the data directly from the Kairos DB, so from the stored data in the Examon database, as well as from Parquet file, which can be used for long-term storage. So in terms of a combination of AI with Examon data, so the first set of work that we have been doing has been in anomaly detection. So the idea was, can we understand by looking just at the data if some nodes or components is having an anomaly? And the idea is mostly of anomaly detection is to correlate, to have powerful tools which are capable of correlating sensor multivariate time series data between themselves and spot out data statistics which are different from previously seen one. The tools that we saw was more effective has been the autoencoder, which is a peculiar machine learning deep learning model, which allows to learn a decoder and encoder of values, which basically recreate a model of a correlation model between the sensors, and when the multitude of sensors which have been collected does not show this correlation, a reconstruction error is higher, and then this can be flagged as an anomaly. So we tested it originally to detect misconfiguration on the system. Then we always put it to a more challenging task. We also saw the powerful part of the autoencoder was the training part that was trained in a semi-supervised fashion, which allows to cope with the intrinsic problem of anomaly detection, which is the scarcity of anomalies. Indeed, the supercomputers are built to work properly, so anomalous points, data points are rare, and so if there is an imbalance in classes between the normal class and the abnormal class, and so semi-supervised approaches focus in training models only on the normal class, and in detecting anomaly when they have problem in reconstructing a data point, which means it has a statistical properties which are different from the nominal one. However, if semi-supervised and supervised training can be combined, we saw that it's possible also to have properties of the model in terms of anomaly anticipations, which means that the model is capable of seeing abnormalous behavior even before the anomaly label is being produced. So it starts to flag anomalous behavior even before an anomaly is happening. This is not a model which has been trained for doing anomaly prediction, but it was showing capabilities in terms of anticipating anomalous. So we then moved to two different models. So with RUAD work, we decided to go from semi-supervised to completely unsupervised anomaly detection model. So by adding also the temporal dimension to the models, so to introducing LSTM autoencoders, so models which reasons of sequence of samples and still are on base of autoencoders approaches, we saw that the model was having better performance when trained unsupervised with respect of semi-supervised. And this is really interesting approaches, because this means that these types of models can be easily deployed on a new installation of supercomputing system, because what you just need to do is to start collecting data, and after 1 month, without providing any labels to the model, this model will start to be capable of detecting anomalies, even if you haven't told them in any way that there were anomalous labels on it. So it's really easy to deploy the system in a system. Then we moved finally to what is anomaly, pure anomaly prediction. To do so, we added, we moved from semi-supervised and supervised to supervised learning, because for doing anomaly prediction, you need to have anomalies labels. And this was done thanks to Examon, because we used, by collecting data from Nagios, we had anomalous labels from the supercomputer, and we had a really productive interface with the system administrator of the Cineca data center in refining the labels for collected by Nagios to have true anomalous labels. And thanks to that, we start to train models which are capable of predicting an anomalous event. So a node which will be flagged as drained by production because of a failure in advance by hours. And the trick that we have been using has been GNN, so graph neural networks. And the reason why graph neural networks are more capable in anomaly prediction than the models that we used before is the fact that we can now feed to the model multiple nodes at the same time. And now the model is capable of differentiating between a seasonality effect which impacts all the compute nodes to a seasonality effect which is a property of only a single node. Because previous model, if you were, let's say, opening the window outside and you had cold air suddenly entering in the room, it wasn't incapable of differentiating between a variation in the statistic, which was a property of the single compute node of their entire room, of a set of compute nodes. Now, by having multiple nodes which enter into the same model, the trained model is also capable to learn what is a sudden variation in the correlation between the features of a single node of a multiple node. So the model is more capable. Here in the picture, we see the capability of the model in terms of providing a failure probability before the failures happens, even hours before the failures will happen. Of course, different models has to be trained for different prediction horizon, which have inherently different capabilities and performance in terms of predicting the failure. We also invested, the next problem is how to put this model in production. We had really thought for years which one would have been the way of putting these models which have been trained offline into production, and we ended up in creating a framework which uses MLOps to have continuous integration and continuous validation of the continuous deployment of the models into a system by leveraging Kubernetes clusters. And this allows really to have to fill the gap between research on data analytics and AI in production. Finally, the last activity that we're working on Examon is to provide ontology. One of the problem of having general end user using the Examon data is that the way in which are stored, because the databases which collect Examon data is completely unstructured. They are time traces data, and there is a need of having a lot of domain expertise in order to understand the data and how to collect and combine them. So we have been working in providing Examon ontology, and in combination to RDF technology, is possible now to have to SparkQL, which uses the graph, which connects the different data points to have more expressive query language to have a simpler extraction of the data. So another line of research where we are acting now is to simplify the usage of the Examon data by the end users. So these last word is also we have been working in frameworks for having prediction at the room level. So we have been doing work in order to predict failures from the cooling system in the data center. So I thanks to acknowledge all the different funding institutions that have been working in the years into the Examon project, and I'm happy to answer to questions. Thank you all for listening.
Thank you both, Andrea and Federico. It was very interesting.
Can I just add one thing
Yes.
regarding the Examon plugins, because there is also a Countdown plugin for Examon related to the job information. So after also Countdown can send its hints and information to this beautiful framework for monitoring and all the things that Andrea showed us. Closed.
Good. Are there any questions from the audience? If yes, you can just unmute yourself or write it in the chat. And in the meanwhile, I have a question about Countdown. Maybe I missed it, but does it also do the monitoring of GPUs? And if yes, is it able to change the frequencies of the GPUs?
Yes, it monitor the energy and power consumption of GPUs. Actually, 100% compatible with VML. To actually change the frequency of the stream multiprocessor is quite complicated. We are dealing with that, but the problem is that the fact is that there is a subset of a function can be called by NVML, which actually to modify the frequency of the stream multiprocessor, but to be able to modify that, you must be root. So to call another another function to let other users. So we are trying to leverage this problem because Countdown actually run on a user level. The cool things of Countdown is that it is actually run on a user level without any root permission on the GPU, on the CNEC infrastructure, because we provide some Slarm plugin which actually give give Countdown capabilities that he needs, and then restore back the status of the nodes on which he runs. We are working also for this frequency modification for the GPUs, but at the moment just the monitoring part is enabled.
Thank you. Are there any questions from the audience? Or maybe there is something in the chat. Question about Countdown. Go Guntram, and then I read it.
One question on Countdown. You showed quite impressive reduction of energy consumption for your specific test case. Do you think this will carry over to most applications? Because I think most high performance codes will try to overlap communication and computation in a way they reduce these opportunities for where they don't have nothing, where they have nothing to compute because of communication, yes, or because of MPI.
Yeah, the question is reported. I mean, that's what I show you. 1 second, I'm sharing the screen. Just 1 sec. This one you were speaking about, that's the average frequency I reported. The final average frequency reported is here. Not the frequency changing during the application events and MPI events. There, to read that values, you need to get information from the tracer enabled at each sample, and then you can find actually the real variation inside regarding the frequency. You can see slowing down, approaching the entering the MPI event, and then scaling up once they texted.
Yeah. Was this done for a specific application, or